Hello everyone, welcome back to Everything Swift. Today we'll be tackling Leetcode question 1448 titled Count Good Nodes in Binary Tree. Basically, the definition of good nodes is that particular node, and we are going to compare it with a maximum value that we're going to pass in this traversal. If that particular node's value is bigger or equals to that maximum value, it is considered a good node, right? So I think this example here demonstrates it pretty well on what we are supposed to do. So let's use this example and I'll explain exactly what we are supposed to do, right? So we're given a binary tree here with a root of 3, right? So what we're going to do is we're going to traverse and we're going to check like is how many good nodes are there in this binary tree. So let's say we traverse to the left side, right? So the root node is value 3. We pass down to the left side because we're traversing left. What we're going to do is we're going to check if 1 is greater than or equals to 3. No, it's not, right? 1 is smaller than 3. So this node here, this 1 here, is not a good node, right? So before continuing traversing down below, what we're going to do is we're going to compare the two values and find out whether there is a new updated maximum value, right? So 1 and 3, between these two numbers, what is the maximum value? 3 is greater than 1, so the updated maximum value is 3, and then we pass that maximum value down here, right? So we check again, is this node bigger and equals to or equals to the maximum value? Yes, it is, right? 3 equals to 3, so this is considered a good node, right? So far we have seen two good nodes. So traversing to right is the same thing. We pass the root value down. So now we ask, is this node, which is value 4, is it bigger than the maximum value that we pass, that is 3? 4 is bigger than 3, so we count that as a good node. That is a good node, right? So before traversing, we check again, is there a new updated maximum value? So 4 is bigger than 3, so the new maximum value is 4, right? So now we pass down 4 to this left traversal, and this node here, which is 1, we compare it with the maximum value of 4, right? So is it bigger than 4? No, it's not. So this node is not a good node, so we can't count that, right? Same for here, we pass down the maximum value of 4 to this node, and then we check again if 5 is greater or equals to the maximum value. So 5 is greater than 4, that is a good node, right? So as we can see here, the answer is good node is 4. So we have 1, 2, 3, and 4, right? So looking at this example, the assumption here is root is always treated as a good node because there's nothing else to compare with. So 3 is greater than this invincible number. Root node is always treated as a good node, right? So as we can see just now in the explanation, what we're going to do here is the strategy that we're going to use is a pre-ordered traversal, which is root, left, and right. Right? We're going to traverse at every node, and we're going to pass down the updated a maximum value, and then we're just going to determine if that particular node is bigger than the maximum value. If it is, we're going to increase our good nodes count number, and then we're just going to keep the traversal alive until there's no more nodes to traverse to, right? So basically it's going to involve some recursion, and I think this general concept is called depth first search, which is called DFS. So yeah, that is basically the gist of it. Let's jump straight into the code and see how we're going to solve this. So I'm going to check if root is nil. If it is, well, there's no good nodes, right? Because it's empty. And then what we're going to do here is I'm going to create is results variable, which is of type integer that represents the number of good nodes that exist in this binary tree, right? So I'm just going to return this result here. As mentioned, and most commonly in all depth first search DFS solution, we're going to use a recursion. So I'm just going to set up our recursion function here. I'm just going to call it traverse. And what we're going to do here is, obviously, like I said, at every traversal, what we're going to do is pass down the particular node and also the maximum value, the updated maximum value. So we obviously need to pass in the nodes to traverse down, traverse throughout the tree. So root is of type optional tree node and max value, right? I'm just going to make this optional, max value int, and then we're going to pass in the results that we're going to that's coming from here, and I'm going to call it in out because then we can update the results variable within this traversal function as well. So this is going to be type in, right? So I'm just going to do some check here. If root is nil, then basically there's nothing we can do. So we return, and then what we're going to do here is if root node dot val is bigger than max value, bigger than equals to, right? As we can see here, 3 is considered a good node because 3 is same as this, so that's why bigger than equals to. If it is, what we're going to do is results plus 1, right? We found a good node whenever this condition happens. And as I mentioned, we have to update the maximum value while we traverse, right? So let's go ahead and do that. Updated max value. I'm just going to call it updated max constant here, and max of the root node value and the max value, right? And what we're going to do here is, since we have to traverse the entire tree and we are going to do it in a pre-order traversal, so what we're going to do is we're going to pass in the left and right. So we're going to call this is where the recursion happens. We're calling the same function within itself here. So root, we're going to traverse left side, so root left, and maximum value is the updated max, and we're just going to pass in the result to update our answers. Traverse root right, updated max, and result, right? So that should be it. Let's go ahead and call this function here, root. So we're going to pass in the root value here as the original maximum number, and then we're going to pass in the result. So I think that should be it. Yeah, so this is a typical DFS depth first search setup. It's a recursive format. And what we're going to do here is at every traversal, we're checking whether that particular node value is bigger than the current maximum value that we passed in. If it is, that is considered a good node, so we increment our results here that we return as the answer. And then to sort of like traverse the entire tree, we are going to traverse left and right in a pre-ordered traversal fashion. So let's go ahead and run this, and hopefully that works. There we go. That's the solution. Let's try and submit this. And there we have it. That is the right answer. That is the solution for this question. So as always, I hope you guys find this kind of videos helpful. If you do, please feel free to subscribe, and please share this channel with anyone else who thinks this kind of material is helpful. I'm going to post more video from here on now, so appreciate your support. And as always, take care. Thank you, and bye bye.